Hello and welcome to this lecture. So in this lecture we'll define a couple of functions in order to handle some of the events that can be working with some of the states. So when the player jump, when the player walk, or when the player stand, and when there is a fall, and obviously when the player died. So let's define a function to handle that, and that should be handle state function. And this is important function, so let me just define it as handle state and give a key here, and after that just give file group. So key will be in order to check what did the user basically want to do or wants to perform, and keys are bunch of actions here, and the file group will be obviously the events after that key is pressed. So let's define that is a self.state is equal to c.stand, that is our constant here, and if you just check this instant, so you can get something that is a string type, and that could be stand. So let me just call another function with here, that will be, let me just say that should be okay, standing function, and this standing function will take keys and similarly the file groups. So we haven't defined this standing function, so basically this will take care of all the events that will be done when the player basically wants to stand. So similarly we'll just check if the player wants to walk, so that should be state now equal c.walk. so if it's the case, then we'll just define another function which will be handling all the walking events of the player, and that also takes the keys and a file group. So similarly we'll just ask if the player want to just jump, so that means we'll just say if the state is c.jump here. So if it is the case, then we'll just define another function, and that should be jumping function. So let's define it, so that should be self and jumping. So we haven't created this bunch of the function yet, and after this handle state we'll just be creating this standing, walking and jumping, and it also takes our keys and file groups. And what else the player can do? Player can fall, and player can also die, and also player can change from the small to big size and vice versa. So first we'll just check if the player basically falls, so that means I'll say if self dot state here is equal c.fall. so if it's the case, then we'll just say self dot, now we'll create another function with a signature falling, and argument is keys and file group. So similarly we'll just check now for death, that means we'll say self dot state is basically c dot death jump. So if you wonder what is this c and death jump is all about, go and check this constant.py and search for this death jump, and you can find the string which is basically death jump. So let's create now another function to handle this, that would be jumping to death, basically jumping to death. So it won't take anything, so we'll just make our object to death here. So the next thing what you can do after death is to check if the user basically want to change the size from small to big and vice versa. So I'll say if the state again is equal c.small, and that should be small to big. So in this case what we'll be doing is, now we will just create another function to handle that, and I'll say self dot, and let me make one function that would be changing to big function, now changing to big. And let's define another function that would be, let me say that would be for the big to small. So I'll say that is elif self dot state is equal if the user want to change from big to small, then just create another function that would be changing to small, and that's it. So this will be the bunch of n function that we have to create now. So there is nearly 1 2 3 4 5 6 7 function which will handle our stand, walk, jump, fall, and death, and big, similarly small to big and big to small events of our player. So firstly we'll start with this standing. So I'll say define the standing, and you can say what is the parameter that we have to pass here. One is self, another is key, and another will be fire group. And now what we'll do is basically this function is created in order to handle if Mario is standing still or not. So let's define this function standing now. So firstly we'll just check to allow the jump, and basically this is also the function that will create. So firstly we'll say check to allow, let me say check to allow and jump. So if it is allowed to jump or not, so we'll just pass a key here, and also we'll just create another function, and that would be check to allow to fire or not, allow fire, and now fire bulb, and just to give key here. So after these two function that will be created in a bit, we'll now check for the frame index. That would be like from frame index, and just create it as 0, and next thing you want to do is give the velocity, that would be x and y velocity. So let's create that, and this is basically the velocity of our player. So let me say O here, and self dot y velocity, and this also should be O. So after this, what we want to create is we want to check for the multiple actions here. So if keys, and just give a tools here, this is basically the tool.py, so you can check this tools.py. so we are just referring this class, and we'll say key binding. We'll just create this, we'll just search for the key binding, and if you go here in the tools, you could find here we have something that is a key binding, which is dictionary. So we'll just refer that, and I'll say just get this key now, that means action. So just call this action, and now what you're gonna do is we'll just get this fire to set up. So for that I'll say self.fire and self.allow fireball. So if it is true, then just shoot the fireball. That means we have to create another function again, and that should be shoot fireball, and just give this fire group there. This is basically fire group, and we are good to go with this key action. So we'll check another action that will be down now. So let me just copy it, that is action part, and I'll just paste it here, and instead of action we'll check now, that is if it is down key. If it is down, then what you're gonna do is we'll say crouching should be true. So let me say self dot crouching should be true here. So let me just copy it again, and instead of this action we are going to type a left. So if the key is a left key, then what you're gonna do is we'll say facing right should be false. The users should not face to right, or Mario should not face to right direction, and after that we'll just get out these from the crouching. So that means we'll just create another function, and that would be get out of crouch, and this will handle. So this will handle just making this crouching as a false and do multiple things. So we'll just call this now, and after that we'll just make the state of our game as in walking state. So we'll just walk now. After that we'll do same for the right. So let me just paste it here, and instead of this action, let me say it should be right. And now we'll do same action, that is facing right should be in this case true. And similarly we'll just get out of the crouch from calling this function, that would be self dot get me out of this crouch. So that would be like get out of crouch. And now what you're gonna do next is we'll say self dot state should be now walking state. So this will be right action. So after that we're gonna just walk, and basically we'll just check for the jump now, and that will be like elif. So we have created here a left, and we have here the right, and this should be here elif. So let me say if it is the right, and if it is jump now. So that means if the key is here is tools dot key binding. So let me just copy it again. So let me just copy it and paste it here, and instead of this right we'll just ask for the jump here. So this basically we are just checking this because either the player can move to left or either right, or he can only jump. So this is the case basically. And we'll say if the player can jump, then just make something here, just first check if it is allowed to jump or not. That means if it is allowed to jump, then what you're gonna do is first we'll say if self dot big jump or not. So this basically for this big, and if the big jump is allowed, then we'll just set up now firstly what you're gonna do is if this self dot big, basically if the big jump is allowed, we're gonna just set this state here to an jump state. That means c dot jump here, that should be jump. So it should be small c, that is referring to the constant. And after that what you're gonna do next is we'll just make this velocity of y here, that is y vel should be equal to c dot jump velocity. So this is to allow to jump. So after that what you're going to do next is just stand here. So that means the state, next state should be now just standing state. So the next thing what you're gonna do after this is to check for the down now. I'll say now if not keys and tools dot key binding, and if not is down, basically if it is not down, then what you're gonna do, you will just get out of the crouch. So let me call this function to do that, and that would be get out of crouch. We haven't defined this get out of crouch yet, and we'll define it in a bit. So we have to define this get out of crouch now outside this definition. Let me just go here and define that. That would be get out of crouch, and just pass here a self. So what you're gonna do in this is you will basically get out of this crouch. So that means making the player to get out of the crouching basically. So let's say first get the bottom here, that is from the rectangle. We'll just extract this bottom. So from this statement, that is self dot rect dot bottom, and just get that button first, and now we'll just get the left again, and that would be self dot rect dot x. Position can be left or right, but in this case we'll just deal with the left here. So we'll check if our Mario is facing right or not. So if it is facing right, then this image should be created and this image should be stored as in the right frame and over here. So that means the frame which was basically right frame, in this case we have created, you can just go up here and you can see we have here is a right frames as in 0 assigned as in normal small frames. So this should be particularly this right frame should be assigned to now to this image if it is basically facing to right. So else if it is not facing, that means we have to just assign this image as in left frame here. So let me say self dot, now it should be left frame, and let me just write it left frame, and here just get O again, and let's create a rectangle that is from this image point, and let me say self image, self dot image dot get rect. So this will just create a rect, and after that the next thing you want to do is getting the bottom of this rectangle and similarly the left position, and we'll just set the crouching to be false. So that should be done now. So first we'll say just get me that bottom of the rectangle, and that would be from this bottom. And now the next thing what you're gonna do is self dot rect and just get this x position, and this x position should be now assigned as in left because we are now crouching, so we are just getting out of this crouch. So if you see here, that was in this case we just assigned here left, and we are just giving that back that value from this left because we have just changed here. So after that the next thing you can do here is just a crouching, just make that crouching to be false. So basically this is to get out of the crouch, and the next thing you can do is to check the allow for the jump or not. So if you can see here, here is another function to check, that is basically to allow jump and to check allow for firing the fireballs. So let's make that. So first we'll just say define check to allow jump, just check to allow jump, and that should be allow here and jump, and now just pass a self and a keys that would handle this event, and it should be allow here. So what you're gonna do next is you'll just, so this will basically check to allow the Mario to jump. So first we'll say if not keys, if the key is not pressed basically, and that should be tools dot key bindings, and just pass your as in jump, and we'll just say if it is true then self dot allow jump should be now allowed because jump should be allowed now. And we'll just check similarly for the fireball, that would be from check to allow fireball, and in this case we'll just take a self and a keys to handle this. So we'll say if not keys, and similarly get this tools dot key bindings, this is basically our dictionary, and action, basically action will take care to throw this fireball, and just in that case we'll just allow fireball here, allow just fireball, and that should be true here. So this is basically to allow, so this s should be smaller here. So let's check that if this error just eradicated or not. So you can see here this check to allow and check to allow fireball while we are standing, and you can just go down here and we'll just create another that is to shoot this fireball, that should be shoot and fireball. So this is important function, and we'll just take self and power up group. So let me say power up group. So this will be called from the main when you just want to shoot this firewall. And what you do here is basically you shoot the firewall, allowing no more than 2 to exist at once. So we'll just basically create a firewall count for that. So I'll say self dot firewall count, and this firewall count is basically not to allow the Mario to hit more than 2 firewall at once. So let me just count this now. It should be self dot count and number of firewalls. So this is the basically method which we have to now implement. So it should be number of firewalls, and let's pass here as a power up groups. So basically we'll just check here, that is a current time. We'll just take the current time and we'll just subtract it to the, that is the time that we just hit the last firewall. And basically if we'll just, it is greater than some number, and we'll just count that firewall is, if it is less than 2, then only you have to just fire the ball, otherwise you can't. So let's check that condition. So there should be if and self here in order to get the current time. And I'll say if the current time here, that is this current, that is basically current time here, if this current time, and then after this getting this current time, what you can do is we'll just subtract it through this self dot count, and it should be here as a count, and let me say last firewall time. So it was last firewall time, and if it is greater than 200, so if it is greater than 200, then what you're gonna do is I'll say, so basically this current time is not referencing here, so we'll make that in a bit. So firstly what you're gonna do is we'll just check that if the firewall, or if the self dot firewall count is less than 2, then just self dot allow firewall here should be true. And after that what you're gonna do is we'll just power up this group. So power up group dot add. So what you're gonna add is we'll just add a firewall here, that would be power group power ups and dot power up dot, and that should be, let me say it is power up or ups. Let me go here, power ups, that is basically our component. And we'll say what you're gonna do here. So firstly we'll just add this firewall and just give a parameter that should be self dot rect dot right here. And similarly let me just give y now, that is self dot, so this right is basically x position, we are just traveling in the right direction, that means we are just traveling in the right direction. So let me just give y here, and after that just we are facing here right, so that means we are facing right here. So now what you're gonna do is we'll just basically set this current time to be the last firewall time, that is from this last firewall time should be now basically self dot current time here. So this will be it. So similarly what you're gonna do next is we'll just initialize the frame index to be 6, and we'll just check if the player is facing right here. Then what you're gonna do is we'll just have this image, now this image of a player to be the right frame, so that should be in this right frames, and just give a frame index, so that should be self dot frame index, which is basically here 6. So if it is facing right, so just do this. What if it is facing left? So it should be else self dot image now should be self dot left, so it should be left frames, and just give the frame index here, frame dot index. This should be frame underscore index. So after that, what we're gonna do is we'll just count the number of a fireball. So that should be defined in this function, and that should be count number of fireballs. So this is basically taking this power group again, and this is power up group. This is basically considering that if the Mario has to basically power up to the current state. And now what you're gonna do here is you'll just count the number of a fireball that exists in this level. So firstly we'll say fireball and list, just create this fireball list, and here the fireball will be maintained as a list, and just loop it now to basically get the power up from this power up group. So let me create a new variable for looping. So for power up, in this power up group, what you're gonna check is we'll check if the name is equal to fireball or not. So this basically it will be power up dot name if the name is basically equal to c dot fireball. If it is the name is equal to fireball, then what you're gonna do, so it is same like saying here that is equal to fireball. So let me just go here and just paste it as a constant instead of hard coding here. So basically what you're gonna do here is just I'll say fireball list and just append here with this power up, and we'll just return the length of this list from here. So just return it, and that should be fireball, and that should be first length function, and just give this fireball list here. So basically this function is returning the number of fireball that is in this list, that is in the power up group list. So after that what you're gonna do is we'll just define walking here. So this will just make our player to walk. So let me just define walking, and it will take our keys and fire group if there is any power up for this player. So this function will be called when the Mario is in the walking state. It changes basically the frames. Also it will check for the holding down the run button. It will also check for the jump, and also it adjusts the state, other state if necessary. So we'll just say self dot check here, and it should be check to allow jump, and it will just call through these keys. And after that we'll also call that is the next function, and that is by just checking to allow the fireball or not by this check function, and that should be fireball, and just give key here. So after that what you're gonna do is we'll just check if the current frame index is basically equal O, then just increase this frame index by 1. And what you're gonna do next is we'll just set this current walking time to the current time now. That means make this walking timer equal to self dot current time. So let's get this current time and just set it at the walking time now. So after that what you're gonna do next is just we'll say if it is the frame index is not equal to 0, then we'll check for the condition, that is if the current time, basically if the current time, so this current time can be initialized from this pygame module, that is from the time dot clock, and we'll say subtract here basically, and if it is greater than the speed here, that is self dot animation, let me say calculate, let me just write here some function, random function, and we'll make this function in the next lecture. So I'll say calculate an animation speed, just calculate the animation speed, and it will just return us animation speed from this function. And if it is basically, if the current time minus working time is greater than this speed, then what you're gonna do is we'll just do something, that is we'll just set this frame. So firstly we'll just check now again if the frame is basically at the half of this 6 frames. So here was the 6, so if this frame index is basically half of it, so that should be somewhere to 3. So we'll check this frame index is less than 3, then just increase that self from this. Let me just go here again, remove this, and basically if you see here, okay, so this should be colon here, and after this we'll just set this frame index to be increased by 1, and similarly we'll just set else there should be only one increment, and that is assigning the frame index to be 1 if it is basically greater than 3. So the next thing what you can do is we'll just set this working time again, working timer basically, to this current, and that should be current time here. So this current time is basically our clock time. So now it's time to check for the action. So basically we'll just check for the run button and also for the jump, and adjust the state if necessary. So that can be done from if, and we'll just check now, that is from this keys we'll check if the, just get me the key binding first, and we'll just check for the action first. So that should be action here, and if the action is the key basically, then first what you're gonna do is we'll just maximize our x velocity. So x velocity is basically for our movement, and that should be max x velocity, and this should be assigned as a maximum speed here because we are just walking with an action here. So that should be here max, just give me this walk speed, basically run speed, just assign it is run speed here. After that we'll just basically assign this acceleration, and that should be the x direction to this run acceleration. And basically we'll just check for the action now, that is for this fire. We'll say self.fire and self.allow fireable. If it is true, if it is allowing to just throw the fireball, then what you're gonna do is we'll just call this shoot fireball function here. So that should be shoot fireball, and just give the fire group here. So after that we'll just say if it is not allowing us in order to basically, so this should be here, if the key binding is not an action, then what you're gonna do is we'll just maximize this x velocity again by basically this c dot walk speed. Now it should not be run speed, rather it should be just walk speed, and similarly just maximize, that is the x acceleration, and let me say x, it should be acceleration should be now c dot walk acceleration. So it should not be run here, it should be walk acceleration. And what you're gonna do next is we'll just check for another key binding here, and that should be jump. So we'll say if keys, and just go to here and just give tools dot key binding, just we are calling this dictionary of this tools dot py, and if the action here is now, let me say it is jump, if it is basically jump, then what are you gonna do? So we'll just check for if it is allowing us to jump or not. So that means we'll just call this self dot allow jump, and if it is true, then we'll check for if it is allowing to jump for the big or not. And if it is true, then just set basically state here to be c dot jump, And after that, what you're gonna do next is we'll just check for the velocity here. So it should be somewhere that is here. If it is x, basically it should be x velocity. If the x velocity, that is velocity at x direction, is greater than 4.5 or it is less than minus 4.5, so that means if it is just basically moving within velocity in the left or right direction, then what are you gonna do here? So first check for this velocity is less than minus 4.5. then what you're gonna do is we'll just get this y velocity here, and this y velocity is for jump basically. So we'll say here y velocity should be now reduced. Basically this should be jump here, so jump velocity should be now reduced with somehow between 3 to, let me say, 5 here. Okay, and let me see what is this jump velocity value here. So it should be in constant here. So jump velocity was minus 10, so there should not be much difference. So let me just say 1, or here just 0.5. okay, so after that what you're gonna do is we'll just check the else part, that is here. So what you're gonna do is we'll just set this velocity of the y to be the jump velocity, that is y velocity should be now c dot jump. So after that what are you gonna do next? Is basically just checking for the left, and we'll also check for the right action, and that will be covered in the next lecture.